Well, good evening, everybody. It is 7 o'clock and it is time to start the second in our autumn series of Science for the Community lectures. A few notes before we start. I'll introduce tonight's speaker in a minute, but just as a reminder, this is a series of 6 lectures offered by the University of Maryland Center for Environmental Sciences Chesapeake Biological Lab that is designed to provide you with some of the latest science that our researchers are doing and give insights in where the researchers think the future of the field may well be going. Last week, we had a wonderful introduction to climate science from Hallie Kilbourne. Next week, Jenny Neslage will talk about the effects of climate change on one particular fish species, golden tilefish, off of the Atlantic coast. Jackie Grebmeyer will follow up with a talk on her research on climate change in the Arctic, one of the areas of the planet that is experiencing the most rapid effects of climate change. The penultimate talk in the session is from Dr. Libby Jewett from the National Oceanic and Atmospheric Administration and a co-author on the IPCC report. And she's really going to be talking about how IPCC reports are put together, the rigor of the science that's behind them, the rigor of the review process that goes on so that we in the community can have confidence in their conclusions. And then finally, our own Dr. Slava Lubčić will be talking about how climate risks are changing and how insurance companies view those risks and may change their own policies based on their perception of the risk that they take on when they offer us and cities and large corporations insurance. So we have an exciting series of 4 more lectures to come. But tonight, we are really delighted to introduce a colleague from our Appalachian lab, which is in the western part of the state. And tonight's speaker is Dr. Mark Cochrane. Mark got his degrees from Massachusetts Institute of Technology and Pennsylvania State University, a campus I know well, and then moved on to a range of positions in Michigan and in South Dakota and joined our faculty in 2017. Mark is an environmental scientist that studies landscapes, and particular area of interest is how wildfires cause land use changes on the landscape. He has research programs all over the world, but today he's going to focus closer to home and talk about wildfires on US wildlands and how they are going to be affected by climate change. As always, we will welcome your questions on any aspect of Mark's presentation. Because this is a Zoom conference and not a Zoom meeting, we will not be able to unmute yourselves. So we ask that if you have a question, please type the question into the chat box, and I will moderate the questions at the end, trying to combine common themes together to engage Mark in a discussion. And before I welcome Mark to the screen, I should mention that as ever, these presentations or this presentation series is sponsored by 2 companies who have been good friends to CBL over the years. That's PNC Bank and Southern Maryland Toyota, who have paid for all of the advertising for this series. So with that, it's my real pleasure to introduce Dr. Mark Cochrane for his talk on the effects of climate change on wildfire. Mark, over to you.
Thank you. Nice introduction. So over to the screen here. So as Tom mentioned here, we'll be talking about wildfire, but more kind of getting at where wildfire is headed. Here I'll do a little bit other place, but mostly looking at how in our own backyard, so to speak, being the US, not necessarily right here, but somewhere right here, will be changing. So when we look at wildfire, it's in the news quite a lot these days. We see it, and this is all from this year. It's burning through wildlands, and it's we think of it as horrible often, and most of us at this point know that it is a part of many ecosystems, and you really need it in order to maintain it. And so the fact that there is fire happening out there, even more fire now happening out there, is not necessarily a serious problem. What is, though, is that more and more it seems like these wildland fires are, showing up closer to home and entering into communities and, destroying things that we really would not like to see burned and threatening lives and such. So, the questions here now, well, why is this happening in this way? What should we do about it? And also important is what would happen if we just don't? If we just try to do what we're doing now and hope it gets better. Ultimately, what we don't want is what's happened in a lot of places, the Dixie Fire this year in California, where we're losing more and more homes and lives and trying to do the same thing and hoping for a different result. So fire, what is it? I mean, we all use it, we cook with it, we've, lit matches and stuff. It's just a chemical process that you put heat, oxygen, and fuel together in the right ratios, and you get fire. This a release of energy, burning off the substance, and we get carbon dioxide and we get water. Fire ecology is just trying to look at how that interacts with an ecosystem. So it takes together, the actual science of how a fire works and what it does. So how it changes things. I like it because, if I look at it, it integrates everything. It's how, the landscape fits together, and I look at it dynamically, how it's changing over time. And this is part of a vehicle of change. So the question now is, well, why? What are we talking about here? Well, fire, vegetation, and us, Homo sapiens. Fire is not new. It's been around for at least 420 million years, basically ever since plants moved up onto land. There's been carbon there that could dry out and be susceptible to burning. As soon as we had enough oxygen in the atmosphere, we could have fire. So plants and fire have coexisted for millions of years. Not necessarily always co-evolved, but they've been together. And so they, fire obviously needs the plants to burn. The plants have managed to survive all this time. So it's not necessarily a serious issue for plant life overall. It may change the boundaries for some plants and where they can be and how long they can persist. But we come along. Well, actually, we didn't actually so-called discover fire in the way we use fire. It was actually our ancestor Homo erectus who probably started using fire back over 1.5 million years ago. And our other ancestors since then have been using it. And it's believed that's a large part of why we are who we are today, because those large brains didn't come from, just out of chance. Through fire, we're able to manage landscapes, we're able to process foods, we're basically able to get more energy with less work, so we could have less gut, so we're not like the gorillas anymore or anything like that. And more energy could go into our brains, and so we become who we are today. So, we don't think of ourselves this way, but we are obligate in terms of fire use. Without fire, we cannot persist. You cannot live on just raw food everywhere. You try, but you won't persist. But as a species, we've been modifying landscapes with fire for at least 100,000, maybe 200,000 years. So what that means is we're putting fire on a landscape to change it, either accidentally, but more likely into a form that we want it to be, something that will favor species that we want on that landscape in terms of either plant life or animal life. So if we somehow were able to take fire out of the world, models show that a world without fire would basically have twice as much forest area. So that fire is holding back the forests, if you will. So if you're transforming these landscapes, with fire, what do we get? We have agriculture. Once agriculture starts, we change everything because now we want to be settled. We're not moving around anymore. And so the relationship we had with fire, where fire was a great tool, we used it a lot, suddenly had a negative impact because it started burning things, crops, and homes that we didn't want to burn. So protecting property and our various land uses has as much impact now as our early fire use did before. So before we spread fire around more kind of randomly, if we will, or more widely than it would have been on its own, and therefore we altered the landscape. Well, just the same as we've suddenly tried to take fire back out of a landscape, that landscape is responding as well and changing. So the process is ongoing. I'll talk a bit about the Brazilian Amazon. This is a place where it's not supposed to have as much fire as it has. And the fact that we have changed it and increased the amount of fire is having impacts on ecosystems, even the ones we haven't cut down. And then here in the US, we're the poster child for too little fire in many areas, where we've taken fire out of a system. And this shows how this particular area looked back in turn of the century before we suppressed too much fire, and now more recently. And overall, what we see is more and more forests everywhere we pull fire out of that system, or at least reduced it. So, where my interests lie are primarily in looking at fire, but how that integrates, land cover, land use, land management, and climate change more and more, and all these different aspects that fit together. I've worked everywhere in the US, Brazil. I got a big project ongoing, Indonesia. We're all across Australia, parts of Africa, and other parts of South America. So I've gotten around. And so I have a bit of a broader perspective than many people do, because most of us, we end up specializing in one niche and thinking that fire behaves the same way everywhere. It doesn't. It has kind of different effects for different reasons in different places. So, what's our big problem now? Our big problem is that there's too much of us living in the middle of flammable landscapes. We're kind of a victim of our own success in the places where we pull fire out, because we've been able to suppress fire so well, we think fire doesn't exist there, and therefore we can move in. If we thought there was a lot of fire there, we might not have it all around our homes, the trees. We would have thought differently, but we've been very successful, and now we're also bearing some consequences, because those landscapes are becoming increasingly flammable, partially due to the fact we took fire out and all that stuff is regrowing, partially due to the fact that we're heating up and it's becoming drier and it burns more intensely now. So it's coming at from both ends, and we've changed the dynamic of that system such that fire is starting to regain its place with a vengeance. So wherever there's a vulnerability of our lives, our property, it makes sense that we've tried to prevent that. And so we've done things to try to manage, how we work with fire and landscape, Smokey the Bear, don't like fires, go put out fires. And we go out and we have fire suppression to go out, put out fires once they start. So we're trying to protect things that we think are valuable, which seems quite sensible. But paradoxically, as we're finding out, is as we've done that, we haven't reduced fire risk, we've increased fire risk. Granted, it took a few decades before that really became apparent, but now it's readily apparent that the way we've been managing things has not worked in the way we had hoped. So all that fire suppression and such, together with now we see shifting climate patterns, has resulted in much more fire danger than we would have ever expected even a few decades ago. So, what happens now is that if we're going to manage this well, all of our future, fire and land management decisions, we have to be able to look forward and think about how we want things to play out. We have to think about it as a process, and we can't just say yes fire, no fire. That is not an option. You can either have, less fire now with more intense fire later, or you can have more fire now that's much more manageable. So that we prevent serious things from happening. So, we talk about fire as if it was one thing, or so I think it was like, coat of paint on a landscape. It's not. When we talk about fire, especially as it interacts with ecosystems, we think of, especially we call it fire regimes. What that means is just what are the typical patterns of how things burn, in this area. So a given, say, forest type will have fires that burn certain intensity or range of intensities. They move at a certain speed, they burn a certain area, they happen at a certain time of the year. So all that fits together, and all the things that are in that system have kind of evolved to survive in that system, and that's why that system is there. It's all part of the process. But when we think about fire, we're normally thinking in terms of intensity, how much energy is coming off, or how long it's at a place, so how much time it's had to pump energy into a system. And basically, when we think of fire, we see dead trees afterwards. So it's that idea of mortalities, fire severity right after a fire. Oh my gosh, this is what it did. But in the larger scheme of things, we have to think in terms of, well, how often does that happen? Because if the tree can't regrow and set seed after the first fire and it gets burned again, well, it's gone for good now in that area until a long time for something to come back. Seasonality, if it burns in the fall, you have a very different outcome than if it burned in the spring or the summer or the winter. And then the size of fires, you get a very different outcome if you have a bunch of little fires or big fires, very big fires nowadays. So all of these things come together to create this so-called fire regime that we think of that makes for a kind of a stable ecosystem or dynamic stability. It's changing, but it keeps coming back to what it was before. But increasingly what we now can see is that you can't change the fire regime without changing the vegetation. And you can't even change the vegetation without changing the fire regime. They are linked. You can't separate them. So what this graphic's trying to show you is basically, that normal amount of vegetation on the right ends with your so-called normal fire regime, whatever it is. But if you do something to change things such that, you cut down some of the forest, you've piled up a bunch of stuff that's now dry, you have more fuels, okay, that's going to allow more, say, more heat when you burn something. And so you end up with a more extreme kind of a fire. On the other hand, if you're, suppressing fires, you're going to also increase the amount of, vegetation and eventually have a larger fire. And as we change climate, when we go to a warmer climate, it tips towards increasingly favoring more extreme wildfires. So it doesn't mean they're all that way. It just means they're more and more likely to be more extreme than you normally would have expected or normally should exist in this forest in terms of climate. And we do the same thing in terms of land management. So in a place where there's too much fire, here's the Brazilian Amazon I'm going to talk about for a bit here. It's a large area. It's a rainforest. Rainforest doesn't mean, doesn't make you think of fire. So it doesn't burn that much, but it is starting around the 70s and 80s. We started converting a lot of it, trying to make use of it for people to move into. And to do that, you got to change the land cover because you can't, unless you're one of the indigenous peoples, you cannot live in that forest. So basically, it was like our early days. They said people could go in there and claim lands if they could prove they improved it within 5 to 10 years. Improvement means cutting a forest down. So you get your good old slash and burn where you cut it down, you let it sit there and for a period of months to dry out enough, all the dead foliage, that you can actually burn it and then remove a lot of that biomass and open it up so you can plant crops or pasture for cows. Increasingly, we're going over to soybean or oil palm, but we've changed that landscape. We had to get rid of the natural forest. But what people don't think about, it's not just the deforestation fires you hear about. Those are important, but the vast majority of the fire in these landscapes is not from those fires. It's from trying to keep the areas that you've already cleared from growing back as forest again. Just like your garden, if you weed it once, you can't walk away for the season. You have to keep coming back. Well, say if you have a pasture, it's the same thing. The weeds are actually trees trying to regrow into a forest. And so so often you burn it off to knock them back again. So we have a lot of fire on this landscape. So we also have what we call fragmentation. We've cut up this humongous contiguous forest, and now it has a lot of edges along it. Why that's important is because the way this forest works is it's a rainforest, but it has dry seasons. Dry seasons are a period when there's less than, say, 4 inches of rain in a month. So not our idea of dry, but in the tropics, that becomes very dry. And those forests are very dense. And as they have evapotranspiration, the moisture they put out gets trapped under there and it maintains kind of a blanket of moisture. You couldn't burn anything in there if you tried. And we have. But once you start fracturing that forest or cutting it up, think of it as bleeding moisture. So the moisture can leave those forests more quickly and easily, and that lends them to becoming flammable. And once they're flammable, if you're having fires along those edges quite frequently, pretty soon you have fires moving off into a forest. And what we have are more and more of these forests that start looking like this. Everything should be that kind of dark green. That's what a forest should look like. Everything that's light green or pink of some sort is an area that's cleared and has been put over to either pasture or some kind of other human cropping system. And so, yeah, we have forests there, but it's very fragmented. So those fragmented forests dry out a lot more quickly. The other thing going on in there, even though it looks like a forest, those ones that are still there, they have a lot of logging ongoing. Logging in these areas is different than, say, clear-cut logging that we think of here. There's many, many species, and only a few are valued. So you go out there, you find the few of value, you cut them out, drag them out, and haul them out of this forest. So it's still a forest, but you keep pulling parts of it out of there, and so you fracture the canopy. And again, now it bleeds more moisture, and it also has a lot more potential fuel lying around from all the slash from these logging operations. And here's something we did to actually kind of show this. Normally, if you looked at this kind of a satellite image, the whole thing would look dark green, but we've got a method that helps pop out the areas that are damaged. And what you're seeing there is all those lines are the logging roads, and all those dots, those are so-called patios where they stack up the logs that they're pulling out. And you see some areas look kind of faded and some areas are bright. The bright areas are the new logging. The faded areas are back a few years, but this forest has been logged. There are little roads all through it, and then there's slash and fractured areas. So it's not actually a forest. Much of it is not a forest that's intact. So we get more and more things like this. This is the first fire I ever saw in the tropics, and didn't seem that impressive at the time. It's 4 inches tall. But that, in fact, is an extremely severe disturbance for this system because it's not supposed to burn. It's a rainforest. So what happens is you get something like this. This particular area, the foreground had burned before, but the area where my colleague is walking into, it looks like a cave because it's the rainforest. It's very dark and lush. But a fire came through, and a week later, it looked more like this, where all the leaves are dying. It didn't like burn up into the canopy like we see in the West often. It crept on through, but it turns out it killed a lot of those trees, and all those leaves start falling down together with bits and pieces of twigs. So, these little bitty fires that don't seem too impressive, like I said, 4 inches tall, they take about a minute to go a foot, so it doesn't seem like much, but it's incredibly important because even though they're very low intensity, that slow movement is what kills trees because the living part of a tree is just under the bark. And the bark of these trees is extremely thin, like 3 times, say, the thickness of the palm of your hand, of the skin of the hand. So it's kind of like, if you move your hand across a candle flame very fast, no problem. But if you had to hold it there for a minute, you get a feeling for what's happening to these trees. It goes through and girdles many of the trees if they don't have thick enough bark. And so what this means is that 40% of all the trees are dying, but it's mostly smaller trees, less than a foot in diameter. And so it's only 10% of the biomass. But what's strange is that after the fire, you have more fuel than you did before the fire, because pretty soon all those things fall down and we have 2 or 3 times as much stuff that can burn within a week or 2 after a fire as we had before the first fire. So, that changes this system rather significantly. So this is the same forest, and there's 2 sides of a logging road. Side on the right had burned, side on the left hadn't. That's the way it should look. That forest kind of seals itself off. It's thick anyways, but all along that edge, it kind of grows up with vines and thick growth. But on the right, you see something that's more like a forest where it used to be able to walk through and move around it. But that one on the right is going to get a lot drier and hotter than the one on the left, to about, say, 15 degrees Fahrenheit warmer. So ultimately, I say all these fires aren't the same. What happens is if we have another fire get into there, there's a lot more fuel down. It's a lot more fuel and it's a lot drier. The frequency of having that first area, you would have to have an extreme drought, 1 to 2 months with no rain whatsoever to even have a hope of burning an intact rainforest. And then slowly. These areas, once they've been damaged, it only takes, say, 16 days or so without rain, which that happens every year. So they become vulnerable. And if it burns more and more, it gets more vulnerable yet. The intensity goes up tenfold because there's more fuel lying around, kills another 40% of your trees, but this time it's killing even large trees. And well, the fuel load goes up yet again. So each time we're getting more and more fuel that's drier, faster. And so we get this ongoing positive feedback. So the system that shouldn't burn starts burning quite a lot. This is just showing you how these forests get degraded. All the pinks and reds, or most of the reds, are areas that were cleared on purpose. The yellows are, with the lines through them, that's the logging. But you see some of these areas like on the upper right where you get like these little ring patterns of yellow, or the ones up the top that are yellow and red. Those are from fires. And what those ring patterns are, it looks like ripples in a pond. These fires, they burn differently throughout a day. They basically go out at night, but they smolder in a few logs. And then about 10 in the morning, they light off, as we found out behind us. And they start marching through the forest. They get more intense during the day. And then as it gets late in the day, they get less and less. And then they get banked over for the night. And then they start burning again. So we get this intensity gradient. You can see it rippling across the landscape here. Over the left, that area had already been logged, so it burned really intensely. That's why it completely deforested some areas. On the right, that's inside of an indigenous reserve. People, and the indigenous peoples live here, and this is an intact forest, and it got in there and it's caused quite a lot of damage, but nothing like what happened where it already had logging. So the take home here, small fires get you large fires, which get you no trees. That part in the bottom there, it was like on the fifth fire, all that standing stuff was trees trying to regrow. It's now dead. The fires came through, weren't that big. And all those white lines, that's kind of like the ghosts of all the remaining trees that were there. They were standing dead. And when the fire got in it, burned, they fell over and they literally burnt away completely. So we have complete deforestation. We told the landowner this and he didn't even know it was gone because he didn't intend it to be gone. So we get this feedback where, you bring people into the system that's not supposed to burn. Well, we put in roads, we log, we open areas of deforestation that fragments that forest. All those things make it much more likely to burn the forest that's there. And once it does burn, it gets much more likely to burn again. And the only way out of that loop is losing the forest or deforested. So unless we somehow totally change how we're using fire in that landscape, we're going to lose those areas. So the study we did, we looked at it, and this is a fairly big chunk of part of the Brazilian Amazon. And the patriotic coloring there is just showing you that everything in black is gone, it's deforested. And that's what we think of as deforestation. But everything in red is going to be gone because the amount of fire in that landscape is too often. It's happening more and more. And so it's going to keep eroding things. And this is where their Forest Service is located. They can't even keep the fires out. So those things, are hard to stop. And so once the frequency of these fires increases more and more, we end up losing that remaining forest. It may take a while, but kind of like I said, you look at it dynamically. Unless you can change that process, everything in red is already ticketed for death, if you will. The other areas, as it moves closer, will probably enter the same phase. That's the Sustainable Forestry project there that's still in blue. So they're working hard to keep that one intact. So ultimately in these areas, we worry about, will big protected areas help us? And I was lucky enough to work to help to establish a big national forest program there. Brazil doesn't get enough credit. Half of the Amazon is supposed to be protected from deforestation, either as indigenous areas where people live, native peoples, or as some sort of park or national forest. This thing on the right that I'm showing you there, you can see all those areas in red are deforested areas. The areas where the parks are, and the indigenous areas are doing a pretty good job of holding back the tide. There's a lot of pressure to develop these areas, and they're working fairly well. Granted, the Kayapo are pretty good about putting your head on a stake if you enter the land. So that is a way of dissuading things, but other areas, they are protecting it, and it seems to be working. The problem is some other areas end up like this, where you see the so-called Bom Futuro National Forest means good future. Turned out it had no future. It's now been dissolved. It's not even, they don't even pretend it's a national forest anymore. That little area that still was intact was actually a small indigenous area that was in the park. So how, the rest of the world? We have satellites now, we get all these images. We try to look at fire across the planet, but we tend to be simplistic about it. Wildfire is very, there's more things going on. It's multifaceted. So even if we know where, when, or even how much area burns, it's only part of the story. This is just showing you the difference between January 2008, July of 2008. So we get a lot of fire. If you notice, most of the fire is actually in Africa. It's all the savanna areas. But look in the US, where would you say most of the fire is? We think of fire is out in the West. This makes it look like the entire East is burning, especially the Southeast. So depending how you look at things, you get very different images of what's happening. One thing we do know, though, if we look around the world, burned area is actually dropping globally, which you might not think, given all the news you see. We're having less and less burned area, less fire. Granted, that was an 18-year swath in this particular one, but even when we look longer term, globally, basically since 1930, the trend has been down, down, down. So all around the planet, we're changing the amount of area that's burning. we go in there and, basically even in Africa now, it's coming down quickly because once we divide up a landscape and, start putting our, crops in and our populating it, we try to suppress fire more and more. And so there'll be less and less fire in those areas. So globally, the amount of fire is going down. It has been for quite a long time. Well, as I've mentioned before, though, less burning equals more fuel. So anywhere you pull out fire, you're going to end up with more and more vegetation that survives. And that's why the prairies turn into shrublands. If you go all the African savannas or Australia, anywhere savanna, if you do a fire exclusion, you'll turn it into a forest, dry forest, but it'll be a forest. So all those areas are going to start accumulating more fuel, potential fuel. We did a study trying to look at, let's look at not modeled projected climate change or anything like that. What just climate change that's happened recently in the last, 30 plus years. We took all the weather that was, recorded and basically looked at how it changed. And when you think about fire, it can only burn at certain times. It has to have certain conditions. So when you define that, you try to create the fire season, when fire happens. And we looked across the planet how it was and how it had been changing. And basically what we found is, there's a lot more of these so-called long fire weather seasons. So if you have a drought that extends it, say normally you could burn a couple months. Well, if it's a real drought, you might go 3-4 months, very long season. Well, more and more of the planet is having that. So all this stuff in red is showing you where it's getting much more likely. Some areas are blue, some areas are getting less likely. But overall, the average is an increase. And some of the areas that are decreasing are just an artifact of when we started the study. But if we look, say, in the US, you see quite a lot of that area, including areas not too far from you, that are getting redder. And what that's saying is you're getting more and more likely to have some of these long periods when you could get to more extreme types of fires. If we look globally, we're more than doubled the amount of area that's in that kind of a stress category in any given year at this point. So, and then also the frequency of these events, okay, that could happen anywhere, it happens anytime. I mean, weather changes every day. Yeah. And these kind of events have always happened. But what's happening is they're happening more and more frequently over larger and larger areas and lasting for longer and longer periods of time. So we did another study saying, so-called mega fires. There's no real official definition for it. So we basically looked at all these fires detected, looked at how much energy was coming off of those fires. So kind of an idea of the intensity of the energy release there. And we took the top 3 out of every 100,000 of those basically, and said, well, that's got to be pretty extreme. And we looked at all those, about 500 of them. And then we looked for news reports, everything else to find out which ones had caused severe damage. And so those are the ones in red, we call it so-called disasters, where they've been declared as a major event and has impacted humans and where we live. Other ones might have been out in the wildlands where we expect them. And so they weren't as important for us. They were important for ecosystems. But what we see are there are quite a lot of these and more, and they're impacting areas where people live. So more and more extreme events. One thing we don't appreciate usually is that, so this is from NPR, Cats out there, thanks for pointing to this. America is designed to burn, always has been since, whenever we first arrived as settlers, European settlement. This is showing you roughly how often things would burn before Europeans changed all the rules. So the Native Americans didn't just live in this landscape, they used it. And one of the things they did a fair amount of was burning, because they wanted to maintain areas in certain species or in certain states that were more amenable for their living. And then natural fires as well, from say lightning strikes, they would spread as needed until some condition changed and allowed the fire to go out. So one thing to look at here is, okay, you can see the whole center of the country. That's, the prairies, they burned almost all the time, it seemed like. But the east really burned a lot. And our neck of the woods, if you will, is not exempt from that. CBL area, if you look, naturally, it's quite a lot of fire. Most of Maryland would be somewhere between 5 and 7 years. I mean, out on the peninsula, a bit less, but a few hundred years ago, there was quite a lot of fire. And even up until about, again, 1930, when they really started suppressing things, there was a lot more fire on this landscape than we can imagine at this point. But in the US, how are we doing? We spend lots of money. We're out there fighting fires, suppressing fires, managing everything to keep fires out of our living spaces. And if we look in terms of the number of fires for the last 35 years, what we see is the number of fires is going down. I mean, what a lot, 75,000 to 60,000 on average. So fires are coming down, which seems like it would be great. There are a few problems though, because the amount that we're spending on each of those fires is ramping up. In that same period, we're spending about 16 times as much for each wildfire if we divide it up per wildfire. And part of that's inflation, but even if you do the inflation adjusted, which it is, that's what you end up with. So it's not that. So something has changed dramatically. Either we've gotten a whole lot worse at being able to do anything, or something's changing. One of the things that's changing is, okay, we're spending 16 times as much. We've got less fires, and yet we're basically burning 3 times as much area in that period of time on average each year. So now I hate averages, as I'll keep going on about, because nothing happens on average. What we have are more and more really bad fire years, and then some more manageable ones. But ultimately, what we're seeing is that we're tripling the amount of area burning while spending 16 times as much trying to keep it from burning. So we're obviously not winning this battle right now, because it's not just that it wasn't more fires, but it's more area, which means the average size of fires goes up. Again, I don't like averages. This is the average size, so it's gone from whatever, somewhere around 20 up to 150 or so, 180, not quite 180. So it's gone up, well, say 4 or 5 fold in terms of average area, but it's not average fires. We're really good at putting out small fires. We're pretty good at putting out larger fires, but when they get huge, like say the Dixie fire, we just gotta stand back and they're gonna burn for months. We try to protect a few areas if we can. But we're having more and more of these extremely large fires that we really can't control. And that's why we're seeing so much more money spent into so much less effect, and so many more houses and lives being lost. So, you see this, especially out west nowadays, where this little graphic here is just showing you the largest fires in California. And all the ones in color versus gray are the ones that have happened, more recently. So this century, since 2000, or in this case 2003. And what you see is the majority of the very, very large fires have all happened recently. And it's not just California. We can look at Oregon, and it's the same kind of a pattern. We're seeing all the big fires are happening now, and we have some long records, so that, like, say Washington here, the Yakult fire, that was back in 1902. And it was the largest fire in their history all the way up until 2014. And now after 2020, it's third. And they keep dropping. So we're having, rare events will happen, things will change, but we're seeing that predominance of these really large fires are happening now, and it's happening right at a time when we have more and more resources to try to stop it. So we're basically not being able to do it, and it's not just on the West Coast. This is just showing Colorado, same kind of a problem. All these fires are happening recently, the larger and larger fires. So, why does that happen? Well, a number of things. One is, we've managed that landscape such that we kept fire out. There's more fuel in some of these areas, but it's also getting warmer. So this graphic here, just showing you that, in the last 20 years, this century now, things have warmed by, they say, 1.5 degrees. So that's there. But that's not what happens. It doesn't warm on average. If we look, the chance of it being more than 1.5 degrees above what we would have thought of normal last century is 13 times more likely now. 2 degrees is 30 times more likely. So it's much more likely to end up in what we would have thought of as pretty extreme conditions just last century. So that's much more frequent. But this is, say, in the US. Now that's kind of averaging everywhere. Another thing here is that little warm spot, that was known as the Dust Bowl. So these kind of little blips on a map can be pretty important. This is averaged over the whole country. I didn't have one exactly for area, but here's saying that, if we look at the whole Northeast, it's actually gone up by 1.8 degrees Fahrenheit, so it's even warmer. We do the same kind of exercise. It's much more likely to be extreme, up to even 2.5 degrees is now we're 19 times more likely to be that far out. So these extreme events, or what we used to call extreme, are more and more frequent. So we're having to change our idea of extreme. But the take home there is all these averages, don't think of them as one number that happens everywhere. If every day warmed by 1.5 degrees, we'd be like, okay, but it doesn't happen that way. So here's just a animation that I got here to illustrate how things are changing. We have a hard time really conceiving of time and how things change. Well, this did a pretty good job of showing that. So this Appalachian fire of 1932, that was the largest West Coast fire in 70 years, but nowadays it's changed quite a lot. So that the lower graphic, that little perimeter is what it actually kind of looked like on a landscape. You can take that area and make it a box, so it's a little easier to deal with. And it's the one on the lower part. And then on the right, it's going to show that there's that fire, and it's the largest one, and then the next 9 largest ones in the West at 1975, and now it'll step through. Just watch how things change over time, though. So, more fires happen. We always have a big fire here and there, but they're not that big and they're not that frequent. Change happens, but nothing too unusual. Finally, this century, though, things start going a little haywire. So very quickly, that fire becomes not the largest, and before too long, it becomes not even on the top 10. In fact, it's not even in the top 20 anymore. So over that period of time, more and more very large fires and much larger fires have happened. There's been 8 wildfires in the last 2 years that are larger than that Appalachian fire that stood for 70 years as the largest fire. The largest ones now are 4 to 5 times the size of that. So it's not just getting over the bar a little bit. This is just quantum leaps of how much more area it can burn. And this is while we are fighting very hard to keep that from happening. So just this year, the Dixie Fire, that would be number 2 on that list. The Bootleg Fire, that would be number 4 on that list. And the LNU complex, which was 2020, actually, they didn't get it on this graphic, would be number 9. So the bottom 3 would drop off and have even larger ones in here, with Dixie almost the size of that top one. So things are changing quite quickly. So, as I think of it now, climate change is now. It's not something you used to think of climate change is to be out there. We talk about it in 50, 100 years, whatever it was. But yeah, it's going to be different then, but it's different already, and we're experiencing it. We're going to experience it more and more. So, we kept fire out, fuel accumulated, but all these warmer conditions are allowing more of that fuel to be available to burn and the fires to be more extreme. And what we see is we're basically doubling the amount of area that's burning because of climate change that we've already got in place. Now, how that's going to change over time, yet to see, but it's not likely to be getting better. How do we know climate's a big part of this? Well, this work we did, wildfires normally at night, it gets cooler, they die back because the fuels get moist. How in the morning you get dew and everything, things don't burn so well. So fires get down and either stop or barely move. But with global warming, people don't appreciate is, it's warming, but it warms mostly at night. We don't normally stand out at night, so we don't think about it. It doesn't cool down the way it used to. Those gases act like a blanket and they just hold in the heat. So they're not making more heat, they're just keeping it from escaping as fast. So it's warmer at night. Those warm, dry conditions are resulting in more wildfires that now burn at night and burn more, more hot. And so we can see this, if we look across the whole country, that they're ramping up more and more. We have more and more fires at night, and the fires we have are, that thing on the right is showing you, they're much more intense, much more energy coming off them. So it's not just the West, though. This is showing here, area where we had the fire in Gatlinburg, Tennessee. This is showing you how dry it was just before that. It was an extreme drought. So even Atlanta was down to 5% humidity, which is It's like being in, Arizona. Fires don't normally spread all day. They were up to say 20 hours a day at this point moving along, but they're still down a leaf litter. But leaves were still coming off the trees. And then a week later, well, we got a big windstorm and it wasn't burning the leaf litter. It burned full trees. It was jumping ridge to ridge, burned into Gatlinburg and then Pigeon Forge. We killed people. We burned up thousands of homes. And, this is in the East. And the people who work there, who have fires in the West, but they work there, they had no conception this could even happen because the conditions had never been this way in their time period here. But this is something we got to start thinking about. The East is not necessarily immune. And it wasn't just that one place. The work we're doing, we looking at across the Southern Appalachians, all those little circles are showing you areas where, things have changed quite a bit and showing you that there were a lot of other fires spread out over this area. And such that if we look at, how it's changed, it's almost like we can see the day it broke. Normally, if we go for years, there's little or no fire at night all through those years. And then suddenly on a day in November, it just suddenly exploded across the entire region. So yes, it was down there all the way to Alabama, but it was all the way up through Pennsylvania. So you can't say it can't happen here. Well, it might. It hasn't, and hopefully it won't. But the conditions are getting more and more extreme over time, or more. The chance of those conditions is getting more likely over time. So we're kind of rolling the dice. The dice are getting weighted a little more over time. And more of us are living in forest. And this is just showing you that wildland or urban interface, over half of it now has happened in that little yellow area there, which we happen to inhabit. So there's a lot more of us living in a lot more forest. And if that forest ever becomes really flammable, it's not going to be quite like the West, but if it becomes significantly more flammable, we have major issues in terms of the amount of lives and value that is at risk. So again, things can change quite rapidly. So this is going all the way back to 1970, showing the amount of area burning in the Southern Appalachians. And then you see what happened in 2016 all of a sudden. So when it changes, it doesn't change smoothly or just a little. It can jump quite dramatically. What do we do about it? So I've been trying to think about this, scratch your head. Basically, we got to realize that we got to think of everything differently. Right now, we think of it as yes fire, no fire. And wherever we live, we say no fire. Sounds sensible. We don't want it to burn. But what we're finding out is that doesn't work, because all it does is, like, water behind the dam. Eventually it's going to happen. And when it does happen, it's going to happen in a way much worse than it would have if we had just let it burn in the first place. So what we have to do is reconceive of things. Now we're doing some jobs that like prescribe fires and trying to manage some of the wildland areas, but we're not really good about doing that near where we live. And that's where we really have to do this. But what we have to think about is not saying, do we want a fire to happen or not? What we want to do is start thinking about what kind of fire do we want to have, or what will we put up with, shall we say, if we do have a fire. And why that's important is because now if I know that's my goal, I know how I have to go at that landscape now. Do I have to cut trees down? Do I have to burn things more often? How often? What do I have to do to change the landscape so that it doesn't burn catastrophically? So that is where we have to start moving towards. We have to start thinking in terms of how we change the landscapes in our immediate vicinity, not the entire country. Wildlands are still wildlands. We don't want to muck them up any worse than we have. We want to let them be natural. But things around us, as climate change, we really have to start being proactive here. Otherwise, you're just going to have Gatlinburg more frequently. We've lost a few more towns out west already. It's going to keep happening, and it's going to happen faster and faster. And so unless we change how we manage landscapes, we're going to experience more and more of it. And as we look ahead, this is looking at the modeling of where the increase in risk for these very large fires is and how it's going to change over time. And if you look, our neck of the woods has its fair share of it, as well as the Appalachians. Other areas may, but we don't have enough data. What the models also tell us is how forests want to change. These are showing different forest types, and it's saying, which forests should be there. The ones we have now, forest types that we're used to, that we live in and walk through, what they want to be by the end of the century if the climate goes the way it looks like it's going. Well, that's all well and fine, these colors on a map, but they don't tell you, how does it get from point A to point B? Okay. The forest doesn't get up and move, the ants don't come and change things. What that's telling you is all those areas that have changed, those are areas that are under increasing amounts of environmental stress. You know, they're in a climate that they're not supposed to be in. Other things want to move in, they're too stressed, they're going to die, they're going to get either bugs or something. Something serious has to happen for that map to change to that degree in that very short period of time. I have my reservations about it being able to, but it's going to be heading that way. So what happens? And so I'll close just saying, thoughts here, if we have a future where we have an increasing amount of ecological stress with climate change, in addition to everything else we do with land use and management, we got some more things to think about here, because that's going to mean more and more. I think this climate pressure. Think the more it changes, the more force is on whatever is there. Everything out there is designed to be in a certain climate. They don't have, like we do, or I did until it burned up yesterday, central air conditioning or something that will, maintain your climate the way you want in your home. Out there, things have to survive whatever range of normal, weather there is. Well, as that changes more and more to one direction, there's going to be more and more stress on those existing systems. So it's going to be trying to change over to something, or something else will want to go in, but you can't move in until something moves out. So these disturbance regimes, the frequency of fires or other types of mortality, we see bugs, we see viruses and such now, are going to impact more and more of that ecosystem, the components, the species. Times of rapid change are not periods when you have increasing carbon accumulation in long-lived forests. Maryland's carbon, plan there presumes that our forests will stay just the way they are and will not change, and especially will not go down in terms of carbon. We might want to think that through a little bit, or we're going to manage things if we want to maintain it that way. The fire regimes we have in our areas now that we've created, which means not much fire, has favored species that are more fire sensitive. And what that means is basically say they have thinner bark. So if you want a more concrete example, it's basically we've got a lot more maples and a lot less oak than we would have if this area used to burned a lot more as it used to. So if we do end up with fires that are kind of out of control now, we might get, even if it doesn't impact homes so much and everything else, we might end up having higher mortality rates than we would normally expect for those types of fires, because the sensitive species will be more likely to die in them. So we can see, more change more quickly than we would expect. And ultimately, the only way to sustain our human land uses, if we're going to live in these increasingly flammable landscapes, is to actively start managing the fire regimes, not the fires. If we wait till the fire happens and go try to put it out, we're going to lose, as we've shown for decades now. And you've seen all across the West, we see it all around the world right now. If we don't manage landscapes so that we can have a fire we can put out, we won't be able to put it out when it comes. And I'll close with that. Australia, they're trying to do a good job with it.
Thank you very much, Mark, for a masterful piece of science communication. Some of the messages I saw from that I really hadn't realized before was quite how much a part of the landscape on the plains and the East Coast fire was. That was something that had sort of slipped my mind. And that graphic about the relative size of different fires is absolutely remarkable, to see how much things have moved forward. So I'll encourage any of you who have questions to please post questions in the chat. And I will do my best to moderate them as they come in. And I'll start, Mark, by one of my own questions. You make the argument that we should manage fire regimes, not fires. So for this part of the country, what might that look like?
Yeah, for here, what we're trying to do is, we do prescribed fires. We try to put more fire into that landscape, but we can do it under conditions that are not extreme, so that it will change either the amount of vegetation or the types of vegetation in a direction that we either want it to go or think it will go. That's another thing we have to think of. We can't keep trying to go back to the past, because the past moved on, and now we got to figure out, are we going to try to hold on to something, or are we going to try to help it along to a future without it having to happen in a way we don't want it to happen? So here it's mostly putting in more fire in more controlled ways, much more than we're doing now. We've been doing some, but we're going to have to do a lot more if we really want to get ahead of it in any respect. It doesn't mean we have to burn the entire landscape, but we really want to do more change, and we can do it mechanically too. You can cut things and change things and open them up, but it doesn't create all the same effects, say, that fire would, in terms of favoring other species and changing things. But around here, it's more of getting a more reasonable amount of fire into the landscape so that we can start moving the species composition into a more resilient mode, and also trying to change some of that so that we're less and less likely to have anything too severe. Thankfully, here with our vegetation, it's much less likely to get up into going through canopies. You need a very bad event to happen in the fall, basically, where the leaves are still on the trees and dry, for you to get that kind of fire. But we still can get quite a lot of fire, even going through those understories and impacting us. And it's not just the fire, as we've learned, it's the smoke a lot of times that is the biggest problem for people. So we can either burn things under manageable conditions and plan when the smoke is going to happen, so you can work with it or stay inside, or it's not that bad, or we have it under the worst conditions when we get more smoke than we know what to even do with, and we have no way of controlling where and when it goes.
So, not to put you in the political hot seat, but one of our attendees, and the name is cut off in the chat box, it's Jack, possibly Templeton or Templeman, says, is Maryland actively sensitive to these circumstances? Is it part of the state planning process, or is it yet to be adopted?
The state is doing some work. I know in other groups like the Nature Conservancy are doing stuff, but they have a hard time. Actually, I think over towards the east, I think they're doing a better job than we are out west in terms of the amount that's been allowed to get in there. And, I've even seen some down even towards DC, they've done some. So they're trying, but everywhere it's usually the issue is people are very opposed to it, because we have this idea of fire very bad, and I don't want to see trees that are blackened, and I don't want smoke around my children and such. So there tends to be a lot of resistance. We see a lot of that, at least out west. I don't know exactly how much we get here, but usually the issue is trying to get enough. Well, you have to have personnel, but you have to have permits and time when you can burn things, because you have so-called prescription windows. It has to be within a certain range of conditions, and you have to get the approval to do it, and it all has to line up at the right time. So ultimately, yes, we're doing some, but it's way less than we need to be doing. And it's not because the people there, they would do more if they could, but they're limited by either resources or permissions.
Okay. So Bill Raines asked whether in metro areas, whether it makes sense for forests to be limited to home building with zoning as flood prone areas are. So should in metro areas sort of zoning and other planning be restricted with fire suppression as part of the planning?
Yeah, in a lot of areas, we want vegetation and trees. They keep things cooler and they do things. What you do is we have out west, they've gone to like fire safe policies and programs where they try to get you to, keep the vegetation back away from your house or certain types of vegetation down. It's not about getting rid of it though. So it's not, and I've seen, like, I used to live in Brasilia, down in Brazil. They get a big giant, savanna in the middle of the city, if you will. It's kind of like Central Park, only bigger. And I've seen fires going through there. They just have that. You can do it in those large areas. You're certainly not going to do it in a neighborhood.
So you spent a lot of time talking about forest areas and savannas. One of the questions I thought was very intriguing from Sarah Hood What's the prospect for Alaska and fire on the landscape as climate change impacts Alaska?
Yeah, I mean, it's there, it's much more natural, we say, we do some fighting, but most of it is allowed to burn. So it will kind of go over, with less of our interference probably. But there too, it's more frequent, larger fires. What happens there is you start burning down into the duff layer, and you can change the whole species composition, whether you're favored like black spruce or white spruce. It's not my area of expertise, but I've seen that. And there, even if we go up into tundra areas, we're starting to see more fires there. That gets more important too, because you start exposing more areas and so-called permafrost, and we can speed up the rate at which those areas melt. So yeah, we can change things quite a lot, but there it'll kind of, the further north you go, on average, the amount of warming goes up. We say 2 degrees Celsius or something for the planet. Well, that means like 6 degrees up there. So they'll see it a lot faster, but I don't know exactly how it's going to go.
One specific question. Why do small, low-intensity fires create more fuel? Wouldn't they just consume the fuel and grow into big fires? And that was from Katie Lynn.
Yeah, that's a good point. No, what happens is, okay, you have a certain amount of fuel there, all this leaf matter and small vegetation on the ground. It burns through there, but it kills the trees. The trees then, fire's already gone past, but within the next few days, things start falling down, and they keep falling down. Things decay rather rapidly in the tropics. And, like I said, within a week, I've had some places where the fires have gone out, and then a few weeks later, it came back. And we had one place where it came back a third time in the same year. So it takes a while for it to kind of replenish. So it's not like it's just all at it immediately. So it has to die, dry out, and fall, and then you can start having fires again. But what normally happens is it burns for 1 year, but then a year or 2 or 3 later, it comes through. But now there's a lot more stuff that's fallen, and so we have a lot more fuel on the ground, and then it dries out and burns more intensely.
Okay. Another specific question, and certainly having been out west and seen the massive scars on the landscape, and I'm aware of the increased risk of mudslides, but is there any measurement of the impact of forest fires on the rivers and streams in those areas that of which you're aware?
Yeah, I don't get into it, but there is okay, you see, mudslide, landslide, all that. I saw a lot of that when I was Idaho, for example. You get that a lot. But yeah, so you end up a lot more silt, you end up a lot more material in general in those streams. Some ways it's kind of more natural because we used to have stuff in there, but at the scale we're having it, it's kind of like too much, too fast in many cases. In any case, it's a perturbation of those streams. I know there's some people working with that. I don't know the data itself. I mean, all the way from there, all the way out to what ends up in the so-called blue carbon there, washes out. Someone recently talking about, how it impacts beaches with everything from fecal coliform on down. So,
yeah. All right, one last question, and then we'll let everybody go. The landscape has become more fragmented, but the fire risk is increasing. Those at some level seem at odds with one another. So what's the connection here?
Yeah, no, that's a very good point. And in fact, that's how the amount of burning tends to go down. We fragment the landscape and it tends not to burn. It burns up to the road, stops, or another field. But that's kind of a signal also of just how things have changed. It should stay down, but what's happened is the conditions get worse and worse, and fragmentation isn't an absolute. It's not like hitting, whatever, the brick wall, so to speak. It's kind of like resistance. So a little bit of wind and it jumps over a road. A little bit more, jumps over a giant highway, even over a large lake. So there's that, or just the amount of energy will allow it to burn through dense, green vegetation as well. So, basically the conditions are changing such that it's kind of like a back and forth. The amount of fragmentation was kind of winning the war against fire, but now the conditions have changed and it's kind of going back the other way. It's not enough to stop. It stops the small fires, which is great. But once it gets beyond a certain point, it just becomes a permeable landscape. We see that out like California a lot with you get the Santa Ana winds going or something like that. And suddenly what was a fragmented landscape now looks like it's just constant, continuous fuel.
All right, great, thank you. Well, I'm going to call an end to it there because of the time. But Mark, on behalf of everyone who was on the conference, I really want to to thank you for a really wonderful presentation that ranging from the Amazon to Southwest Asia to the West Coast to the East Coast, and really made me think about fire in a very, very different way. So thank you very, very much. For those who are on the seminar, it was being recorded. It will be posted to our Science for the Community website. And just as a reminder, we'll be back next Tuesday, not talking about fire, but talking about fish. So thank you all very much for joining us. And Mark, once again, thank you for a great talk. Thanks very much. Good night, everybody.